quarter. So we have to require design of the ship with equally strong stern to the bow. That was also new. And finally, we have the vessel that, in our view, is a state-of-the-art ship, and it was named as a Ship of the Year in 2009. It has double hull, twin screw propulsion system, twin engine room, and it's by far the largest icebreaker in the Arctic today. And if you look at the performance, it's remarkable. If non-nuclear icebreakers existing today in the world, they're pretty equal to this one. The biggest ships operate at the same icebreaking capability, or a little bit even lower. It utilizes the bidirectional concept. That's what's the difference from the Finnish double-acting ships. That implies the conventional bow and icebreaking stern. This ship has icebreaking capability both directions. And uses, of course, new technology as it ports, which is Finnish technology. And you see the ship is quite large, 92,000 metric ton displacement. It has almost 250 meter length over the waterline and can carry up to 70,000 ton of crude oil. The ship equipped with a new technology which called ice load monitoring system. Of course, we aimed the mitigation of the risk, increasing safety of navigation, having potential cost reduction because of less repair. Ice damage happened, and significant ice damage is a common thing in the Arctic, normally fixed in the regular dry docking. But so far, we didn't have anything like that on these ships. It also allows us to validate the hull design for the vessel and propulsion design, and collect some statistics for future projects. The system was developed in joint development project by ConocoPhillips, American Bureau of Shipping, and Samsung Heavy Industry, kind of a fruitful cooperation of the user, operator, classification society, and the shipbuilder. It has a monitor on the bridge that provides the information to the captain, measures every ice impact on the hull, calculates the level of stress in the structure, and demonstrates it to the captain in almost real time with a delay of 1 to 2 seconds. The system uses amazing, another wonderful piece of technology is the fiber optic gauges. It's very important for crude oil transportation because it's intrinsically safe, no electricity involved, only light goes through the cable. We have some experience and learning from that project, definitely. Just to reiterate that the 70,000 ton deadweight tankers, three of them been built in 2008-2009 and chartered by joint venture Naryn Neftegas. The first crude oil was lifted in June of 2008, and we have today already 5 and entering 6th year of operation. Ships never miss the cargo. There's been over 500 crude oil lifts performed and more than 250 million barrels shipped from that terminal. No icebreaker escort ever been used for transit, and the vessel definitely meet the requirements. But what is interesting, that operational performance significantly exceed the predictions. What we predicted during the simulation in 2005, developing the concept of the ship, that in severe winter, the speed in ice will drop down to 3 knots in March, April. This is very tough months in the area. Or on average, for the average winter, it will be around 7-8 knots. In fact, we have this actual speeds that exceed probably by 2-3 knots the prediction for the average year. And all this 5 years been considered as average years. We didn't have a severe winter. We learned some lessons during that project development in the first 5 years of operation. Those lessons can be projected for similar projects in the future, and several factors have been found quite critical for this type of operation development. First of all, the vessel concept should be started at early stage of the project to identify the technology gaps, regulatory gaps, and allow ample time to fix all that and find the solutions. Sometimes it's challenging and takes time to develop. The second lesson is extremely important one. The state-of-the-art icebreaker tanker requires a state-of-the-art ship driver. The training of the crew cannot be underestimated. The new technology, they never operated the ship like that, and it's, I remember the captain of a second ship been talking to me on the bridge, and he was very excited of being a captain of this tanker, and he said, you know, I've been driving many ships in the Arctic. He has like 15 years of experience, and he'd been telling me, but those are like Chevy trucks. This is Ferrari. So, but you really need to know how to drive Ferrari. So that's an interesting observation, and real-time ice information for the captain is extremely important. We have on board the system that tops the satellite imagery and ice charts, so like 3 times a week. We don't have it in real time, but even that is extremely helpful for planning the transit and operations. And of course, at the terminal itself, it's a very complex area, and you really need to learn the ice regime there, the currents, the tides, and some local factors. Like there are two layers of currents, for example. Nobody knew about that at the Varanday terminal, and we discovered that later. When we learned all this, the operations went very smoothly. So the conclusions, I don't know what we can say at the end. Is there enough evidence today to say that Arctic crude oil tanker offtake is a reliable, safe, and economically efficient solution? Perhaps. It's a bit too early to say. We only have 5 years in operation. But the experience with the Varanday system provides some optimism in that respect, and tell us that the well-designed, maintained, and operated vessel can provide safe and reliable operation. Thank you.
Let's take a couple of questions.
A question about the crew training. Did they undergo a number of dry runs before they started taking on cargoes, or?
Answering that question, first of all, the crew supposed to be formed out of experienced ice-breaking operators. Having 3 ships with 2 captains on each ship and double crew was quite challenging to find so many experienced Arctic operations. There was kind of gap in industry a little bit. So what was happening that most of the training was on the simulators and training on the job. But it should be in the future taking farther than that.
Roger Marks, Anchorage. First of all, thank you for coming here. This was very interesting. 2 questions, one specific and one general. The specific question, insofar as you're able to answer this question, is wondering what your per barrel costs are for the ice breaking leg in Varanday, what you're transporting. And general question is, and this might be maybe a better question for the whole panel, but just sort of from technological and commercial perspective, would marine shipments out of the North Slope for LNG or oil in the next 20 years be something that is thinkable?
Well, in terms of the dollar per barrel at Varanday, Obviously, it depends on the production rate, and it's variable over the life of the field. I don't have at the top of my head the numbers, but it's a little bit higher than conventional, what we used to have, say, $2–3 per barrel. That's probably double of that, $6 to $7 per barrel. That's the range. At least that was predicted. What the actual outcome today, I cannot tell you because, first of all, I'm not working on that project anymore. And secondary, because the production rate has been changed over these last 2–3 years. So, but that's the range. Answering the second question about the overall perspective, like I said, I cannot make too general conclusions because this is a specific project and it gives the optimism. And if we did it here, I don't see the reason why it can be done in the different places all around the Arctic, including the Beaufort Sea as well. So I don't see the reason why it cannot be done. But like I said, it needs to be specific. Thank you.
It's my understanding that a bow that's good for the open ocean isn't good for ice breaking and vice versa. And I wonder if that was a trade-off you had to make in designing this ship and what the outcome was.
In terms of designing of the hull form, the bow?
Yeah, as I understand it, this is an icebreaker at both ends,
Yeah.
including the bow. So the question is,
Right.
would you have an ice-breaking bow in open water? How does that work?
There are two trends today in designing the ships for ice. The one is called double-acting ships that have conventional open water bulbous bow, which provides the great performance in open sea. When we're talking about the great performance, we have to remember that we're talking about seakeeping mostly. So this type of bow provides a better performance on a head sea and definitely reducing the slamming at the bow. But in terms of resistance and speed, icebreaking bow is quite good in open water, I can tell you. So it depends on the purpose. We had a shuttle operation, and for us, imperative was ice transit, because the crude oil was taking to the market on the conventional ships. So we also didn't have icebreaker support. If you have icebreaker support available, you can do many other things. With this ship, you're on your own, no help around. So that must be icebreaker, and it must be icebreaker that can do anything in the ice that requires by the situation. Otherwise, you may be in trouble. So for us, there was no, that's what Finns suggested, to do the conventional bow. But in the Russian Arctic, for example, it's prohibited to have the bulbous bow, so we couldn't go for that anyway. So we had to go for some kind of ice-breaking bow. If we had to do it, why don't do it very efficient? And that was the premise for the design.
Thank you.
Why don't you take a comment there? Yeah.
Yeah, is it on? Oh, yeah, good. No, it was a comment, there was a question about the Beaufort Sea and whether we would see this kind of icebreaker tanker, not supportive of the icebreakers up in the Beaufort Sea. While it might be technically possible, I'm not sure politically, environmentally,
Absolutely.
you name the issue. And of course, we have the pipeline. I think all plans are to trench a pipe from the offshore, whatever exploration and development, to the beach and link to the transatlantic pipeline. I don't think there's there hasn't been given a great deal of thought that there would be a shipboard transport system, tanker system that would maybe take this oil to global markets. I think it's going to the pipeline to fill the pipeline, which is not filled. So I think while it's technically possible, I'm not sure all the other dimensions, including economics, might be the right place for a shipboard transport system.
Yeah, I agree with that. Personally, I found pipeline quite ugly, but but they certainly compete with the tanker Optic, that's for sure.
It's beautiful. It's beautiful. One last question.
Yeah, actually, two quick ones. The first one is, can you tell us a little bit about the oil field itself? Is it right there at the shore? Is it onshore? Is it offshore? And who the owners are? So that's quick question number one. Second, is there any possibility that this technology could be used for LNG at some point in the future?
Okay, I will try to answer those questions without going in too much details. Yes, the oil field is located onshore. It's an onshore development, and the owners of that oil field in joint venture, Narimar Neftegas, formed by ConocoPhillips and Russian oil giant Lukoil. Currently, ConocoPhillips is no longer the part of this joint venture, so we assume that Lukoil is the only sole owner of this oil field beginning this year. The oil is pumped to the tank farm onshore, and from that by pumping station 11.4 nautical miles or 20 kilometers to the loading terminal that I have shown you on the picture. That's how it works. So the oil is brought to the storage on shore and then to the pumping station. That's all I can tell you about this. Did I answer the question?
And the LNG.
The LNG. Well, the LNG is, in terms of shipbuilding and designing it for the Arctic, is not much different, but it has own specifics, of course. The LNG ships are quite large by definition, because the specific gravity of the LNG is is the half of what we have for the oil. So if you want to carry the same amount of metric tons on LNG, or normally in cubic meters measured, you really need to build a large ship. And the larger the ship is, the more challenges, because it's a huge resistance. It's a length that not helping in the ice for maneuvering and for dealing with ice pressure. So the LNG is a bigger challenge in terms of ice breaking technology. But generally speaking, the approach is quite the same. It's different design inside the hull, but outside it's going to be pretty much the same.
Okay, we need to move on. Give a hand. Next up we have Patricia Cochran. She was born in Nome, Alaska. She's the executive director of Alaska Native Science Commission, worked on numerous research projects in the Arctic, the administrator for the Institute of Circumpolar Health Studies, science advisor to the U.S. Arctic Research, advisor to the NSF Office of Polar Programs, and has written numerous articles. Here is Patricia Cochran.
Thank you very much, and good morning, everyone. I wanted to shift gears a little bit, if you don't mind, and speak from an indigenous perspective as an Alaska Native and as somebody who's had the great opportunity of not only living and growing up in the Arctic, but I've had a lot of experience working with indigenous people all across the Arctic as well as worldwide. So let me start, if I might, in the way that I've been trained in my community to begin everything that I do, by first of all acknowledging that long before Captain Cook was here exploring this area, there were a lot of first Alaskans that were here, and that this land is really the land of the Dena'ina, the local indigenous people who lived here long before. So I recognize them and give them thanks for allowing us to be on their land and to speak on their land. I've also been taught that it's important for us to honor and to remember all of our elders who are here among us, and to remember all of our ancestors who have come before us. In our ways, it's to help to ground ourselves in everything that we do, starting out each day by thanking the Creator for the beautiful day that has been given to us. So thank you for letting me start in my own traditional way. I wanted to ask, how many of you went to the Alaska Native Heritage Center last night? It was pretty cool, huh? It's a beautiful place, and I'm so happy that you all have seen some wonderful Alaskan weather while you are here. Just so you know, it's not really typically like this, but we're all enjoying it as well. So we hope you had a great time out there. Got to see a bit of our communities as they used to be in each of the village settings there, and also had a chance to have some fun with our traditional Native games and sports, and recognize their significance and importance. So let me start out in saying that I have to talk about things really from a sort of a larger picture perspective, because that's the way that things operate in our native world, that we really see things as everything being connected. That you can't separate the environment from the human being, the sky from the land, from the animals, that really all of those things are connected. So for us, looking at the opening of our waters is just one of a myriad of things that's happening within our communities. And so I wanted to start by talking a bit about a project that I've had the great opportunity of working on for the last couple of years now. And this is the Draft National Climate Assessment. I've been honored to be one of the chapter authors for both the Alaska Arctic chapter and for the Tribal Issues chapter as well. The first time ever that there's been a tribal chapter done as part of the National Climate Assessment. This won't come out until next year, but this is from part of an earlier discussion that those of us who've been involved in NCA gave at a conference earlier this year. So these are some of the things that have come out of our draft National Climate Assessment. Some of the key issues, one of them obviously warming, that Lawson and others have already talked about, that we've already seen an increase of at least 3 degrees more and more in other areas. There are a lot of consequences that come along with that: human health, infrastructure, habitat, native food sources, ecosystem, invasive species, tourism. All of these things are part of issues that we're dealing with. So on health issues, these are just a few of the things. Damage and disruption to water and sanitation infrastructure. In that bottom picture there is the village of Newtok. Many of you have heard about one of the villages that is actually relocating here in Alaska now because of problems that they're having in erosion and storms and everything else. They're actually having to relocate their village, or in the process of that now. But their water system and sanitation system obviously is not going to be working very well in these kinds of conditions. So these are some of the things that they're seeing. We're also seeing changes in wildlife causing certain different diseases, in marine conditions with foodborne illnesses that are happening, milder winter temperatures. And certainly one of the things that we have all seen this year in particular is a whole lot more mosquitoes, bugs, flying insects that we've seen in a long time. So these are just a few of the examples of health issues. Erosion, declining sea ice, and threats to life and property, and the need for resources for relocation. On the left part of the screen there, you see my hometown, Nome. And you see some of the devastation that has occurred in my communities because of the loss of the sea ice, the shore-fast sea ice that used to protect our communities. That sea ice would stay there, and we were able to, the storms wouldn't move into the communities. But now you can see my brother's house on the other side of this surging storm. We used to call them 200-year storms. Did anybody remember that from way long ago? And then we started 100-year storms, 50-year storms, and we've seen a lot more than that just in my lifetime. So this is pretty consistent for us with living in the north. On the right-hand side, you can see one of the villages in Shishmaref, where they literally are losing their communities because of coastal erosion. Oops, sorry about that. Permafrost issues. Permafrost in Alaska is warmed already about 3 degrees. It certainly has impacts on our water and sanitation, our infrastructure, ecosystems, and of course one of the things we're really concerned about is methane. We all know that that's a really huge issue and is going to become more and more of an issue as we see the releases that would be coming not only from Alaska and the Arctic, but especially some of the latest research out of the Siberian caves that have a lot of methane problems. We know that from seeing the sloughing that's happening in our areas already, that Alaska and the Arctic has been a sink for a lot of these contaminants and other things that have been coming into our areas because of ice and because of the wind and water patterns. But now, from being just the place that's been getting all of those contaminants into them, we're now becoming a source of those contaminants as our permafrost is melting and we're releasing more of those gases into the air. We're also beginning to notice that our traditional ice cellars where we store our food, especially up north, they're all melting as well, so we're losing a lot of our food that we used to be able to store safely within our areas. Of course, the infrastructure has to do with the airports and roads and everything else that we're losing along with the permafrost. Ocean acidification is occurring more rapidly in cold waters, impacts again on our ecosystems, and a lot of things that we don't really know how that's going to affect. We're certainly seeing some changes in the shells of many of our animals, like the crab and other species like that. So we know that those things are already occurring in our waters. Wildfires is another major problem that we're seeing there on the left. Yes, that is the Trans-Alaska Pipeline in the foreground. So of course we have some concerns about the wildfires that we're seeing, threats to life and property, and a lot of the human health impacts because of smoke that's coming from a lot of the forest fires. During some of our seasons we have lost hundreds of millions of acres already of land and forests. We're also seeing a lot more because of the infestation of spruce beetles, so that makes the forest much more susceptible. We're seeing millions of lightning strikes, so that's again occurring within all of our areas and is increasing our vulnerability and our concern with wildfires in our homelands. Glaciers, our Alaska glaciers are losing mass. We have only one advancing glacier in the state, in the Yakutat area. All the rest of them, as you can see, are receding glaciers. Freshwater discharge is approximately from Alaska, and the Arctic is similar to that from the Greenland ice sheet. People don't really think about that. People always hear about Greenland and what's happening there, but we have so many glaciers here in Alaska that we're going through exactly the same thing, and we'll have an approximate similar discharge to that from the Greenland ice sheet. It's not just here, but when we also look at the glaciers around the world, in the Andes, in all of the rest of the world, same problem. Implications for global sea level rise, salinity, temperature, sedimentation, and what that does to all of our animals, our fish species, and of course ocean currents. We do recognize that there are opportunities that are coming from the opening of the Arctic waters. We know that there will be increased tourism season. As a matter of fact, we've already had a number of boats that have made their way mysteriously up to the shores of Barrow. One morning they woke up to 400 German tourists who suddenly appeared in their homelands. But being the great, creative, adaptive people we are, we immediately got out all of our tourist sales ware and sold a lot of things to those German tourists. So it was a win-win. We also know that there will be increased research opportunities for our communities, looking at Arctic marine transport, longer seasons for resource development, including mining, offshore, exploration, etc., longer growing seasons for a lot of our farmers, employment and educational opportunities as well for our communities. However, we also recognize that there are numerous challenges that will face us, including transportation and shipping. Tourism, as I said, we are already experiencing a lot of issues or a lot of people that are coming into our areas. The fishing industry we're very concerned with because so many of our people still live from the land. So as we say, our Safeway store is where when we open our front door. That's where we go shopping. So our critters and our animal, our land environment are really important to us. Industry and development are key areas of concern for us. We're looking at potential spills, air pollution, noise, discharges, all of those things. Species and habitat disturbance, and of course search and rescue, which has already happened, as we know, in several of these areas. So we recognize that there are benefits, but also some challenges that we need to be very much aware of and part of discussions. So let me move to a couple of other issues here. Let me talk a little bit about a group that I was involved with as part of the Arctic Council work. When I was lucky to be the chair of the ICC, the Inuit Circumpolar Council, for several years, and represented the Inuit Circumpolar Council on the permanent participants to the Arctic Council. I also chaired the Indigenous Peoples Secretariat for the Arctic Council, and was the representative to the United Nations Permanent Forum on Indigenous Issues. So I really had a chance to not only see what was happening in the Arctic, but really with our neighbors all across the world. So these are some of the things that came out of our Indigenous Peoples Working Group from Arctic Transform, a group of people who were talking about Arctic issues from all over the Arctic nations. First, some of the background information was that we recognized that climate change will have a significant impact on marine and terrestrial animal populations, affecting population size, structure, reproduction rates, and migration routes. That Indigenous peoples will feel these climate change impacts first and most intensely. That there's concern over major irreversible impacts on Indigenous communities and livelihoods. That Indigenous peoples maintain a strong connection to the Arctic environment, and that provides them with economic and nutritional basis for survival, but is also very important for social identity, cultural survivability, and spiritual life. We know that housing, infrastructure, and transport connections of coastal Indigenous communities are seriously affected by climate changes, with rising maintenance costs and sometimes even the necessity of relocation. That Indigenous peoples of the Arctic will need to strengthen their languages, their music, their art, and their literature to help maintain a healthy identity. That Indigenous peoples are increasingly diversifying their economies by engaging in industrial activities. But we also saw a number of gaps that were pretty significant to us. That Indigenous peoples